Lesson 2.2, solving one-step equations. So remember, the goal of solving an equation is to isolate the variable. So our goal is that we want to get that variable all by itself. And how do we do that? We use inverse operations. So we're going to ask ourselves some questions. We're going to say, what's the variable? So first of all, let's find our variable. Then we're going to say, what's being done to it? So are we adding something to it, subtracting something from it, multiplying it by something, dividing it by something? And then, what's the opposite? And that's what we're going to do to both sides of the equation to get that something away from the variable. So some examples, these should be review. If we're going to need to solve by addition, so we have x minus 34 equals negative 5. So what's my variable? X. What's being done to it? I'm subtracting 34 from it. What's the opposite? Add 34. But I have to be fair and equal in my equations. That equal sign is like a big wall. And if I add 34 over here to the left side of the wall, I have to add 34 over here to the right side of the wall. So plus 34. And the reason that we do the opposite is because it makes it cancel out. Minus 34 and then adding 34 makes nothing. So all I have over here is an x. That wall is like my equal sign. And then I just do the operation that's over here on this side. So I do negative 5 plus 34, and I get 29. I can also solve by subtraction. So I look at my equation, I say, where's my variable? M. What's happening to it? I'm adding 16. What's the opposite? Subtract 16. But again, here's my wall. I have to be fair. I have to subtract 16 on this side. So the minus 16 and plus 16 cancel, and I have just my m left over there. And negative 12 minus 16. Don't forget that that looks like this. Negative 12 minus 16. Zoom, zoom, says negative 12 plus negative 16. My answer is negative 28. Okay, I can also solve by multiplication. So if I have negative g over 18 equals 3, I say, okay, what's my variable? G. What's happening to it? It's being divided by 18. So what's the opposite? Multiply by 18. So I'm going to say, okay, take this times 18, take this times 18, divided by 18, and times 18 cancel. Now be careful. I still have this little negative here. So he has to stay there. Now I have negative g equals 3 times 18, so 54. Then I say, I don't want to know what negative g is. I want to know what positive g is. So I'm going to change the sign on the left side, and I'm also going to change the sign on the right side, negative 54. Okay, I can also solve by division. So what's my variable? Y. What's happening to it? Be careful. I'm not subtracting 4 from it here. I'm multiplying by negative 4. So what's the opposite? Divide by negative 4. So I'm going to divide both sides by negative 4. Those negative 4's cancel and make y over here. Negative 20 divided by negative 4 is positive 5. Another way that I can solve is by using the reciprocal when I'm dealing with fractions. So if I have 4/5 y, so y is my variable, I'm multiplying it by 4/5. But remember that property, that multiplicative inverse property, that says if I multiply this by the reciprocal, then 4/5 times 5/4 equals 1, and 1y is the same as just writing y. So I'm going to multiply both sides by that reciprocal, and I have 10 over 28, and then I'm going to simplify that and put 5 over 14. Now, how do we check? How do we know if that answer is right? We substitute the answer back into the original equation. So let's take one that we already did. So we already solved this. We added 34 to both sides, and we got x equals 29. Now, let's check that. If we go back and we figured out that x equals 29, so if I go back and substitute in here for this x, 29 minus 34 equals negative 5. And then what I'm going to do is I'm going to, in my mind, cover up this side of the equation, and I'm going to do this side. And when I do 29 minus 34, I can do zoom, zoom, and that gives me negative 5. And over here on this right side, I already have negative 5, so I'm going to say, okay, I have negative 5 over here, and those two are equal to each other, so I must have done it correctly.